The topic 2 is about capacitors and inductors. These capacitors and inductors are also the passive components, as we have seen in the topic 1 about a resistor, which was also a passive component. Here we'll see in detail about capacitors and inductors in this topic. Capacitors, the definition is a capacitor is a device that stores electric energy on two conducting plates separated by a finite gap between them in the form of a voltage. So basically capacitors stores electric energy, electric charge in the form of voltage. These are the various examples of how a capacitor physically looks like. These are the different types of capacitor. The first one, this one is a electrolytic capacitor. The second one and the third one are the ceramic capacitors. So capacitor is a two-terminal device. This is coming to the symbol of a capacitor. The first one is this is the symbol of a fixed capacitor where it's being represented by two parallel plates separated by some finite gap. And the polarized capacitor will have the charge on both the plates, positive charge and the negative charge. So we'll use different indication to represent the positive plate and the negative plate. The straight line represents the positive plate and the curved line will represent a negative plate or the negative terminal of the capacitor. The next one is variable capacitor. If we want a fixed value of capacitance, then we can go for fixed capacitors. In case if we want to go have variable values of capacitance ranging from some minimum to a maximum value, then in that application we can make use of a variable capacitor. Variable capacitor is a three-terminal device wherein the two terminals will be fixed, the third terminal will be variable. By moving this variable terminal, we can vary the value of the variable capacitor in the required range from a minimum to a maximum value. Now coming to the units of capacitor, the units of capacitance are farads. Practically, we will go for will make use of either microfarads of capacitors or nanofarads of capacitors. We'll never go for farads of capacitors for any application. The next one is the classification of capacitors. Here we can see the classification is basically they are broadly divided into two types of fixed and variable. Fixed goes with electrolytic and electrostatic, and electrolytic capacitors are of two types, tantalum and aluminium capacitors. Electrostatic capacitors are ceramic, mica, plastic and paper, and the variable capacitors are also once again ceramic, air, mica and plastic capacitors. Now this coming to the inductors. Inductor is also a passive electronic component that stores the energy in the form of a magnetic field. This is how practically inductors looks like. Inductor is also a two-terminal device. Yeah, here we have the symbol of inductors is a fixed inductor, air core fixed inductor symbol, iron core fixed inductor symbol, and ferrite core uh, fixed inductor symbol, and this is a variable inductor symbol wherein the value of the inductance can be varied by making use of a third variable. And the units of inductance are Henry. Coming to the classification of inductors, inductors are also broadly classified into two types as fixed and variable inductors. Fixed inductors are of air core and iron core and ferrite core types. Variable inductors are single tuned and tapped types. So, with this, we have completed the topic of capacitors and inductors in brief. Thank you.